Hello everyone, in this video I would like to discuss about the ifelse function. Let's start from the beginning, that is from the difference between the if function and the ifelse function. Let's generate a sequence of numbers from 5 to 15. Now let's check if this object s is greater than 10. If this is true, we want the function to return the value yes. We may think to use the if function. If our conditional statement s greater than 10, this is true, do something. In our case, print yes. Let's run. Now, as you can see, the function does nothing and it prints a warning message. The first question is, did the function work? What is this warning message? Basically, we need to understand that warning message means that the function indeed is working. But R is telling us that something is unexpected. To understand this, let's run the second line of code here. In this case, we have conditional statement if s is greater than 4. Let's run this. As you can see now, the function returns the value yes. So the function is working. Now, to understand what is happening, we need to understand this warning message. So first of all, here the warning message just replicates our function. As you can see, it's this one. And here is this one. Now, what does it tell us? Let's read. The condition is length greater than 1. And only the first element will be used. Let's focus on this first part of the message. The condition is length greater than 1. What is this condition? Basically, it's our conditional statement. So this s greater than 10, s greater than 4. Let's check the length of s. As you can see, it's 11 because there are 11 elements in s. So let's continue to understand what is doing here the function. Let's add an else condition. So in this line of code here, if s is greater than 10, we ask the function to print the value yes, else otherwise print the value no. Let's run. Let's check that now, as you can see, the value no has been returned. So this confirms that the function indeed is working. But how it's working? And to understand this, we need to read this second part of the warning message. Only the first element will be used. So what is the first element of S? Is 5. So let's see here. If 5, this means first element is greater than 10, return value yes. But because it's not greater than the value than 10, the function does nothing because in this case we don't have any else statement. In this case here, if s is greater than 4, and in this case again the first element is 5, so this means if 5 is greater than 4, print value yes. And because this is true, the function prints value yes. And here, where we added the else statement, if s is greater than 10, because s again is the first value, print value yes, else print value no. And in this case, because s is not greater than 10, the function returns value no. So let's see another example here. Let's store 10 in A, and let's run the same code just by replacing s with A. So let's run this. And as you can see, the function returns value no without warning message. And if we check length A is 1. So that's the point. The if function is not a vectorized function. So we need supply just a condition with length 1. What about if we want to use the if function with the any function? This is what we are doing here. So basically, If we run this code, we see that the function return value yes without warning message. What is happening here? Basically, we nested the any function inside the if function. Let's run only this any, and as you can see, this any is checking if there is uh, a number in S that is greater than 10. And indeed, we have numbers greater than 10. So any is true. And because this is true, the if function is returning value yes. Let's see for example, let's change this to 20 and let's run again. As you can see now, the function return value no, because if we check the any function, returns value false. So as you can see here, if we want to check if there is any element, we could use the any function inside the function. But usually we don't want this. We want that any element of S will be evaluated by the function. And to do this, we need to use the ifelse function. The ifelse function is a vectorized function. Let's see how it works. The first entry here is the conditional statement. Then, in the second entry, if it is true, we ask the function to do something. In our case, is print value yes. If it is false, in the third entry, do something else. In our case, is print value no. Let's run this. And as you can see now, we have no because the first element of S is 5. 5 is greater than 10, it's false. Therefore, returns value no. This no is for 6. Is 6 greater than 10? False. And here, for example, it's yes, because this is for 11. Is 11 greater than 10? It's true. Therefore, it returns value yes. Okay, so now we make the distinction between the if and if-else function. Now let's focus on the if-else function only. And let's import this package. Let's load this package dplyr. Okay. So we are making an example with random numbers. We are using this function that generates random numbers. And it's good practice that when we work with the function that generates random number, to, to, to set a seed by using this set.seed. Let's try to understand what it's doing here. So let's run this code. Let's check it. So here we have this X object. We have 100 elements with a minimum value of 1 and a maximum value of 1000. And here we are just checking the first 6 entries. So now let's remove it. Let's remove it. As you can see, we have the X object here. Let's remove it. Now let's run again. All these three. And as you can see, we get the same values. Now let's remove another time. And now let's run only X. Let's check it. And as you can see now, the numbers are different. If we run again X, the numbers are different. Let's run now again with set seed. And as you can see now, we have the same number as before. So the set seed makes the examples with random numbers reproducible. Okay? So now let's move here. Here I'm just generating a Y object that stores A replicated 25 times, B replicated 25 times, C replicated 25 times, and D replicated 25 times. As you can see here, the length of X and Y is 100, so they have the same length, so we can build a data frame. Let's check the first 6 entries. So now, what we want to do is generate a new column here that we call Z that takes value 1 if X is greater than 500, 0 otherwise. This means that here we expect to have a 0 because 266 is less than 500. Here we expect to have in the z column a 0 because this is less than 500. And here we expect to have a y in the z column. So let's run. So again, this is conditional statement. If x in the df data frame is greater than 500, returns value 1, else returns value 0. So let's run and let's check it. And as you can see, as expected, we have a 0, a 0, a 1, and so on. For example, this is greater than 500, 1, less than 500, 0. But now, let's say that we want to add multiple conditional statements. For example, we want to generate a new column W. In this case, we want to check if x is less than 500, x is between 500 included and 800, and if it's greater or equal to 800. So in this case, we need to use in an if-else function inside an if-else function. Let's see. So this is the new column, W. If else, this is the first if else function. And this is the first conditional statement. Okay? The first entry of the first if else function. If this is true, this is the second entry of the first if else function. So if this conditional statement is true, return value 0. But as you can see, in the third entry of the first if else function, we have another if else function here, where the conditional statement is if x is greater or equal to 500 and x is less than 800, return value 1, otherwise return value 2. So let's run, let's check it. As you can see here, we have 0 for the z column and for the w column. Why? Because this value is less than 500. So in both cases, we have 0 value. Again here, we have 0 value for both. Here we have one value because this number is greater than 500 and is greater than 500 and less than 800 for the W column. But here you can see we have different values because this number is greater than 500. This was the conditional statement for the Z column. This value is greater than 500 but is also greater than 800. So this was the conditional statement for the value 2 in the W column. So let's see an alternative. So for the alternative, we are going to use the case underscore when function from the dplyr package. So how does it work? This one is the first conditional statement. This is our second conditional statement. And this one is our third conditional statement. So let's focus here. Conditional statement x less than 500 tilde, this is the Spanish accent. If this is true, return value 0. Then we have comma, second conditional statement. If this is true, return value 1. And finally, we have the last conditional statement that is x is greater or equal to 800. If this is true, return value 2. We're storing this in K, and we just expect to have the same results as the W column. Let's run and let's check. And as expected, W and K, they have the same values. Okay, let's make another example. This is a little bit more interesting. So let's import a table from the Premier League website about the top scorer, all-time top scorer of the Premier League. So let's go on the website of the Premier League, search for top scorer Premier League, and here, in my case, here is the second web page. Let's open it. Here, let's change for all season. So these are the top scorer of the Premier League. So if you watch the previous video, you already know what we are going to do. Right click and inspect. So now, as you can see, this table is identified by this table. So this is the word that we are going to use to import this table in R. But here, let me show something else. Okay, this is filter. Open, and as you can see here, it says data drop down default equal all season. This means that the code that we are going to use in RStudio, regardless if we are on this exact filter, will import this all season. Import this data regardless if we set the filter to all season. Okay, so let's go back. I can make actually a next video with more information about this, how to import data from web pages. Let's go back here. The first things to do is to store the web page address. Let's do. And now we need to read with the read underscore HTML function. Sorry. We need to load this. Okay. So now let's read it. Okay. So this code is the same code as the last one. So just we are just importing that table. Let's run. Okay. And this is our table. As you can see, this is a list, and also from here, this is a list of just one element. And here we are just extract this table from this list. Check. We have here our table. Now let's remove this last column with missing values. This is column number 6. Let's run this code. Okay. So now what we want to do with ifelse function? This stat represents the goals of these players. So we want to generate a new column here, top scorer, that takes value low if the player scored less than 130 goals. Take value medium if the player scored between 130 included and 160 excluded. And finally, uh, take value high if scored more than 160 goals and less than 200 goals. In this case, takes value high. If score more or equal to 100 goals, takes value top. Let's see how we build this. As you can see, we are nesting ifelse function inside ifelse function. The first ifelse function is this one. And this is the first conditional statement. If this is true, return value low. Else, as you can see, in the third element, in the third entry of the first ifelse function, we are placing all these. So in the third entry, we open another ifelse function where this is the conditional statement. If this is true, return value medium. If this is false, so if we have false here, we write in the third entry of the second ifelse function, we write another ifelse function, where now the conditional statement is this one. If this is true, print value high. If it is false, print the value top. And now, as you can see, if this is false, we check this one. If this is false, we check this one. And if this is false, the last value will be top. So the last value here in this code is consequently greater or equal to 200. Let's run this. Let's check it. So we have our column, and as you can see, Alan Shearer and Wayne Rooney, they scored more than 200 goals. So we have top and top here. Then we have Paul, Aguero, Lampard, Henry, Fowler, and Defoe, and they have value high because they score between 160 included, but less than 200. And by the way, let me say this about here, Frank Lampard was amazing. 177 goals as a midfielder is really amazing. So let's go back here. Here we have medium because this player they scored between 130 included but less than 160, and then we have this one low because they scored less than 130. Now let me say this. Since we are importing this table from the web page of the Premier League, that page will be updated. So this means that you may find different values by the time that you replicate this video. Above all here, as you can see, Sergio Aguero, Harry Kane, Vardy, they are still playing in the Premier League. So for sure they can make other goals in the rest of the season. So you may find some different values. Okay, now let's do the same but with the case underscore when. We are generating here a new column, a top scorer 2, and as you can see, this is the first conditional statement, this is the second conditional statement, the third conditional statement, and here we add this fourth conditional statement, greater or equal than 200. Okay, so let's run, and let's check it. And of course, as expected, we have the same values. So, in my opinion, I prefer to use case underscore when we are in this kind of situation with multiple if-else condition, even though naturally this if-else condition works fine. So this is my personal opinion. Let me know in the comment which one you prefer. And with this example, we conclude this video. If you enjoyed, see you in the next one.